So last time we were simplifying trig identities, and I always find it interesting that this is the next lesson because I think it's easier because last time we were simplifying trig identities, you don't have an answer, so you just kind of have to go with it and hope that you're doing it right. But today, we're going to be verifying or proving the trig identity to be true. So it's kind of nice because they give you, once again, the answer, like where you have to end up. So you can know in your heart that you have reached your goal. Because they give you an answer. So everybody, if this says prove that this is true, if you think about it, it is, I'm telling you, it is always easier to take an uglier side and simplify it down to be a prettier thing than take something and make it uglier. So it's easier to simplify than make things ugly. So we would choose to take this side, and you should not be working with both sides if possible. So if the other side is pretty dang pretty, and that is, you're not going to touch that side. You're not going to move from both sides of the equation. You're not allowed to do that. You'll take this side and simplify it till you've reached your goal, which is that. So let's look at some examples. Let's actually just do this one that I have on the board. So guys, understand though, there are so many ways to simplify things that there's not just one right way. In fact, it's really funny how we did it. If you went and watched, like how we did it last time, some of the problems, if you went and watched the video, I do it completely different another hour because we figured out an easier way. Yeah, so let's look at this one. Can anyone tell me what you would, and honestly, you kind of have to just think, where should I start? Any suggestions? That is, okay, yes, he's thinking completely in a totally different direction than I was, which is not wrong. So what is, he said, let's change secant squared minus 1 to be what? It is tangent squared? It is? Okay, so you're saying this is tangent squared theta over secant squared theta. Okay, let's keep going. Then what would we do? Okay, so you said that this is sine squared theta over cosine squared theta. And then we have divided by what? Divided by 1 over cosine squared theta. So dividing fractions is easy as pie. Flip the second and multiply. So then they divide out, and we've now reached our goal. Okay, awesome job. Yes, round of applause. Okay, let's look at this one. So which side is uglier? This side. Let's take this and make it that. That side's quite pretty, in fact. So we're not going to touch that side. So with this one, you're going to want to put it together. To put it together, you need a least common denominator. So we would multiply by 1 plus sine of theta. 1 plus sine of theta. Over here. 1 minus sine of theta. 1 minus sine of theta. Now remember, you have to multiply out your numerator. You can leave the denominator factored. I'm going to throw in parentheses if there's 2 terms. And we might want to multiply out the denominator. It just depends on the problem. So multiplying out the numerator, we're going to have 1 plus sine of theta, true? All over, the bottom actually we will want to multiply it out because I'm thinking it's going to become cosine squared. So if we multiply this out, we're going to get 1 minus sine squared theta. Okay? Does everybody see why? Then right here, we're going to multiply this out. It's a plus sign, luckily, because here's where a lot of people mess up usually, is if that's a negative, they don't distribute it through, but it's plus. So we have plus 1 minus sine of theta, and then the denominator is 1 minus sine squared theta. So now your next step is to combine the numerator correctly. 1 plus 1 is 2. Plus sign minus sign is gone. So we have 2 over 1 minus sine squared theta. We were able to put them together. Now you'd say 1 minus sine squared is cosine squared. So this is equal to 2 over cosine squared theta. Fractions are the least favorable. So we would want to bring that cosine up. So that would be 2 secant squared theta. And then you've reached your goal. Only a couple more examples and then we'll be done. Okay, so with this one, This is not as pretty side. This side is great, so let's leave that alone and let's try to get there. So tangent squared plus 1, is that an identity? It's not? Well, remember how I gave you an identity paper? You should definitely have that out. That is what? So we have secant squared x, and then what's this? Careful. Negative sine squared x. Everybody? So times by negative sine squared x, and then you'd say secant is, so we have 1 over cosine of x times by negative sine squared x. You have to show work. You can't just say, oh yeah, I see that it's that, because that defeats the whole purpose. So then you go like this. So that's negative sine squared x over cosine squared x, which is equal to sine over cosine. Yeah. Negative tangent squared x, and then you'd be able to put your check mark because you've reached your goal. Okay, let's continue. Now looking at this, which side is really better? You're really going to try to only touch one side if possible. So does anyone know which one would be better? Yes, this one, because there's only one term. So let's take this one and see if we can make it that. So tangent of x. So we have this tangent of x plus 1 over tangent of x. Does everybody agree? Because cotangent is 1 over tangent. So to put this together, wouldn't I need a common denominator? So I'd multiply by tangent of x, tangent of x. So then right here we would get tangent squared x over tangent of x. Then we have plus 1 over tangent of x. Now we can put the numerator together. Don't start dividing that back out and end up right back where you started. Add the numerator, so tangent squared x plus 1 all over tangent of x. Then what's tangent squared plus 1? Secant squared x, I believe. So we'd have secant squared x tangent of x. We're trying to get there. I can see it, but I'm just trying to see if you guys are going to see where to go next. Yeah. Okay. Okay, I like his point. He's saying secant is 1 over cosine squared. Then on bottom we would have, he's saying, sine of x over cosine of x. Good thinking. Then we would, dividing fractions easy as pie, flip the second and multiply. So then we have cosine of x on top, sine of x on bottom. So doesn't one of our cosines divide out? Okay. That's going to put cosine on bottom, isn't it? So then we're going to have this. 1 on top, one of the cosines divided out. So we have 1 over cosine of x sine x. True? Which is, we don't want those on bottom, so secant x, cosecant x. Wasn't that our goal? Cool. There was other ways we could have got there. I don't care how you get there, as long as you can get there. Awesome thinking. Okay, so just a reminder, so rationalizing a denominator. If you have 2 terms and a radical, the way we rationalize is multiplying by the conjugate, and you have to do that to the top and bottom. That's how we would, what we call simplify it, right? Simplify it. So if you were given this and asked to make one side equal the other, I think, honestly, when I look at this, that this side's prettier because there's no fractions. Do you agree? Okay. So I'm going to take this side and try to make it that side. So do you see how we have 1 minus sine of y? There's no fixing that. Well, there is, but I mean just right away. There's no fixing that right away. So the only way to bring that up and fix it is to multiply by the conjugate. That's why I brought up the conjugate thing. We learned that last time, but... So we multiply by 1 plus sine of y. You're not doing that to both sides of the equation. Remember, there's really not an equal sign here. Do you guys get that? This isn't solving, it's just simplifying. So then we have 1 plus sine of y. Let's see if this was the right choice here. We would need to distribute out the numerator. So then we would have cosine of y plus sine y cosine of y. Let's distribute it through, and then we might end up factoring it back out in a minute. Now on bottom, I would get 1 minus sine squared y. So we would have on top cosine of y plus sine y cosine of y, and then what's the bottom? Cosine squared y. Is everybody seeing what? Now you say, I need to simplify this. Do you see how there's a cosine in each term? Well, then on top we should factor back out the cosine. Then left would be 1 plus sine of y, right? Divide by cosine, divide by cosine. That's why I got 1 minus plus sine. Then on bottom we have this, cosine squared y. Don't one of those divide out? So now what do we have here? 1 plus sine of y over cosine of y. What's our goal? I don't even remember at this point. Not that, I swear. Okay, there it is. So now what we would want to do is split this apart. You can split apart a numerator. Do you guys all understand that? You just can't split apart a denominator. So let's write this as 1 over cosine of y plus sine of y over cosine of y so that we can bring that up. So what's 1 over cosine? And then sine over cosine. And then that was our end goal, wasn't it? If we remember. Yeah. Cool. Okay, we're almost done. This is my last example. So with this one, I had decided last year that it was kind of hard to make these sides equal each other without manipulating both sides, but maybe we could do it. So, because if I look at these, they're both almost equally as ugly. Don't you agree? So, at times, if they're both equally ugly, it would be probably appropriate to use both, to simplify both sides until you get the same thing. So if we were to simplify this side, what would I do? We can't split apart a denominator though, right? Yes. But good thought. Yeah, so this is another one where do you see how this doesn't simplify to be anything underneath? So we'd want to multiply by the conjugate. So 1 minus cosecant theta, 1 minus cosecant theta. So now you can multiply that in. So then we'd have cotangent squared theta minus cotangent squared theta cosecant theta. And that's all over 1 minus cosecant squared theta. Pray that that's an identity, or else that was no use to us. Is that an identity? It is? It's negative cotangent? Okay, thank you. So we have this now. Cotangent squared theta minus cotangent squared theta cosecant theta. And then you said that this was negative cotangent squared. Well, now we could factor out back on top a cotangent squared. So factor out cotangent squared back out on top, and then left would be 1 minus cosecant theta. And then on bottom we have a negative cotangent squared theta. So won't these divide out? So then it's negative, this divided by negative 1. So let's rewrite this correctly, everybody. So wouldn't that become negative 1 plus cosecant theta? Well, and not necessarily. It doesn't need it anymore, necessarily. Because we've distributed the negative 1 through. Yeah, good thought. Almost. Now look what, though, I might not even need to take this side because, well, we could, but, so isn't that, I'm going to write it backwards. Positive cosecant minus 1. What? There it is. This is 1 over sine of theta, which this is pretty, now we're making it uglier, but we're just trying to make it match this side, right? So we have 1 over sine of theta minus 1. And then what did they do? They got a common denominator. So I didn't even need to take the other side and manipulate it. But we could, because look, we could then make this equal to this. Look, if you split up this, won't we end up here? Okay, so let's just do that, because I don't like making it uglier just for the heck of it. So this is not bad. No fractions, and we couldn't put the terms together. There was nothing we could do to put them together. Does that make sense? Now this side would be 1 over sine of theta. So this is the other side. And then minus sine of theta over sine of theta. So isn't that cosecant theta minus 1? So I am going to take both sides just because I don't like people starting to make it ugly, because then it defeats the purpose of learning an identity. Cool, that's the end. So there's the assignment. It's on your paper as well. You got quite a bit of time still left in class. Please work on these.